Hi, Guy Moses with my water filtration system design challenge presentation. I had a small group today at the end of the day due to scheduling, so I decided to make this a more genuine experience for not only myself but also the students by doing it with them. I facilitated, but I was an active player in both groups. Um, we discussed and came up with both solutions as a group. I thought it would be beneficial to see how this is applicable in a true life or close to true life teaching arrangement. So we started off with some background information. I just put the question out there of how many people have ever heard or remember the water cycle, and the hands shot up. So everybody at least had some type of inclination of how water cycles through our Earth. And one of those hands was Calvin. So I asked him to explain his understanding of this water cycle. And we have some of his visuals to the left there.
Water, first the water is in the cloud, and then it rains, and the water is out of the cloud, and then it goes on the land, and then it flows, and then it flows into a lake or any body of water, and then evaporates.
So this was the basic understanding of the water cycle, and we said that in the runoff stage of the water cycle, this provides a crucial point in which water seeps into the ground and gets filtered for human consumption. And it really, we would be in trouble as a human race if it weren't for that stage. And I kind of offered that to them based on the prior reading I did before this design challenge. But it offered a base of, or a transition really, into the next piece of background knowledge, which I said, does anybody know what is below the grass? And we basically came up together with this visual, which is on the right. We knew that there were sequential layers underneath the grass, each layer being made of a different material. We didn't really know what that material was. As a group, we couldn't come up with names for those levels, but we knew there was some type of sequential order underneath. So I did offer to them the names, and so we came up with humus, topsoil, subsoil, fragmented rock, and bedrock. And we talked a little bit about each one just so they had some background information. So the experiment consisted of the goal or the task of creating a water filtration device that emulated the layers of the Earth. The materials they were given were the ones from the pack. I also included them Dixie cups, pins, tape, scissors, some dirty water, some dirt rather, coffee filters, anything they needed in order to make their device. As a group, we decided that stacking the cups on top of each other with some holes in each cup would emulate that process of filtration. We also, I offered the question of, okay, what materials would go or relate to each level of the ground. And so they came up with, or we as a group came up with, cloth being first, alum, sand, charcoal, and then gravel. So they set it up, and we essentially waited for the results. While that was going on, I kind of shifted to the next group in which we had a little bit of a different design. We decided for faster filtration we would use a little more gravity, and also we saw that the other group's pins weren't necessarily holding up, and so we decided to stack one on upside down on one another. This was actually Gabby's design here, and the reason I put this picture here is because she was just ecstatic that we chose her design. She was super excited and wanted to see her design succeed. So that for me was a really cool moment, so I decided to add that. They did switch charcoal and sand for whatever reason, but that was their design or our design, and so I had Gabby explain it really quickly.
All right, so this is the second try. This is group number 2. They decided to not only switch the order of materials up, but also switch the design up, as you can see. Gabby actually had this idea within our group, so she's going to go ahead and explain it for us.
So the other cups we had to hold up because the pins kept falling out, and we had to design a way to make it stand on its own. So we thought by putting the end on the end of the top of the cup, that it will hold itself.
Okay.
Okay, so we related that to if we had to do this in the real world and it had to sustain itself, how could we do that? So she came up with this. I was super proud of her. The results, I took apart our design by the end of the day. Each level essentially had water in it, but we ended up with some water in the cup. That was Gabby's design, Group 2. And then, unfortunately, I didn't get a picture of Group 1's results, but I did get a video. So these are my conclusions. Basically, I took a video of each. If it'll load here. I had to do it externally. For some reason, it wouldn't load into the presentation.
Okay, so all my lab partners actually have gone home for the day, but I gave it a little extra time to filter down through the process. I've taken all the dirty water, but much better than what.
I apologize. I'm trying to keep within time, but this is having some trouble loading here.
This came out of my faucet. Going to the other.
I'm going to skip ahead to hopefully seeing both cups here.
Taste to it. Ugh, okay.
I tried both of them, and basically my conclusion was that the clear one on the left,
I would choose.
although it looked clear, it had a funky taste to it, whereas the one on the right was a little dirtier, but tasted a little less funky, if you will. I wouldn't drink either one of these out of the faucet, but if I were to, need it in the wild or in a place where I didn't have clean drinking water, this would suffice. So I thought both groups did great. I got a lot out of this, and I would absolutely try this with my science class. I thought it was great to see both of them working through the process, and I actually learned a little bit too. So thank you for listening. Sorry I went over a little bit, and sorry for the technology difficulties.
There's the one on the left, but